is from Brüggemann-Klein, Lyuben Dimitrov, Marouane, Sayih, and it's about a graphical user interface tool for designing model-based user interfaces with UIML.
Thank you. So, as mentioned, we're going to talk about mainly about an approach for doing model-based user interface development. And this approach is wrapped around a small graphical user interface tool, which is a sort of as a proof of concept for our approach. My name is Lyuben Dimitrov, and first, let's start with some challenges to prototyping user interfaces nowadays. In the past couple of decades, we have witnessed this vast proliferation of different sort of devices and platforms, and these devices introduce more and more users from different educational backgrounds, cultural backgrounds, which is a real challenge when you want to develop user interfaces for different platforms so that these user interfaces are consistent between the platforms of one single application, let's say. And you have, on the other hand, this huge diversity also of programming environments, programming languages for each specific platform. And this is how this thing is a real challenge. And it's related to the approaches of user interface development. So the dominant approach that nowadays is this traditional Windows and widget toolkits, where the widget toolkits are reusable elements of and libraries of user interface elements managed by these traditional Windows managers. For example, in the web platform applications, we have HTML, JavaScript, CSS, or in the desktop platform applications with languages, and we have, for example, the Windows Forms or Windows Presentation Foundation or JavaFX and so on. And apart from this traditional approach, there is then the model-based development approach, which the idea is that you have a set of very abstract models that are not technology dependent, and at the same time, they are also not modality dependent, meaning that you define one user interface which is suitable for use on touch, on traditional mouse and keyboard interaction, or even gestures, or nowadays virtual reality and so on. And the model-based approach captures the semantics of the user interface rather than the specifics in terms of for concrete platform. There are some benefits that we can briefly go through. For example, the higher level of abstraction, which it sometimes makes it easy to conceptually catch the most important aspects of a user interface, and also being very abstract and being able to generate from these abstract models and to enhance them into some final user interface for different platforms. You have reduced efforts and reduced cost. Also, this can lead to faster time to market, which is important. And when you're building around some model from the very start of your whole application lifecycle process, this ensures some guidelines that you can follow and to be consistent to some extent. And it can involve non-programming professionals and domain experts. It can increase the interaction of all stakeholders during the whole process. And being abstract means that it's less sensitive to technological change. There is less risk of becoming obsolete, to say. But there are also some drawbacks. Of course, there is this high threshold drawback, meaning that there is a steep learning curve for new users, and it also requires developers and designers currently to have a different mindset of how to capture UI representations in a declarative, abstract manner. It has also low ceiling, meaning that the current state of model-based development doesn't support a large diversity of devices and platforms, and at the same time, it doesn't produce always the same quality as the traditional dominant approaches can target. There is also a lack of model-based tools, good quality tools, which is somehow related to the high threshold because the presence of good quality tools diminishes this threshold and allows more users to enter into this development process. Sometimes it's also difficult to understand and capture behavior in an abstract manner and different levels of abstraction. And also if you need to change something in your user interface or in these abstract models, then it's a challenge. How do you propagate these changes across the different models? But these, of course, drawbacks are all addressable. As mentioned, the good quality tools can lower this threshold and also improve the ceiling, since with a good tool you can create a very personalized and modern user interface, for example. And our goal is to devise such an approach for model-based user interface development with a user interface description language. These description languages are usually, they belong to the XML family of languages, and they're meta languages, meaning that they can capture anything. We also wanted to specifically target XForms. XForms is, it was intended to be the next generation of XHTML forms for the web, capturing user input from forms in a very structured model view controller pattern as well. And also we wanted to use as much XML technologies as possible when we use also some transformations with XSLT and so on, which we'll go into detail. And there are many different description languages for user interface, but we particularly picked one, which is called UIML, or the user interface markup language. We picked it since it has a very clear separation of concerns, which we're going to see on the next slide. It is very easy to learn, so it has a low threshold, since developers and designers do not need to get into a huge amount of new information. It can define very abstract models, which is what we wanted, and allows you to extend its vocabulary by without actually changing the language. And this is very flexible in terms of new metaphors, UI metaphors that you want to support, or new platforms and so on. And since it's open standard, it integrates well with other XML technologies, and it also means that it remains compliant to these technologies in future. It tries to answer some of these questions, and it's based on this meta interface model, which has two components: the interface component on the right and the peers component on the left. So the interface component is, as we said, this clear separation of concerns. It has the structure, style, content, and behavior. So it tries to, the structure captures all the parts that consist the whole user interface. Each part is given unique ID, so that you can reference it within the document or set of documents, and a class. This is literally exactly the same as how CSS, the cascading style sheets, work. The style captures, of course, some specific representation characteristics of each part. The content would reference text that you can switch at runtime. For example, if you're doing a user interface with different languages, it captures images and so on, stores images and so on. And the behavior maps how the user interface interacts with the underlying application logic. The peers component does these mappings to the actual logic and to the actual presentation, which is the concrete presentation that you target, being HTML or C# or whatever. This is a sample Hello World application document, which should render a Hello World window with the Hello World text. And it has this interface stack. Currently, here we have only structure and style, since we don't need, let's say, behavior for this. And some details are excluded for simplicity. such as the peers component. And our approach for this model-based user interface development is based on this well-known and researched chameleon reference framework. It's a meta-architecture for capturing different levels of abstraction, such as this task model, which captures all interactions the user carries out during runtime. It has this then abstract user interface, which is platform and modality independent. Then it supports this concrete user interface, which is now modality dependent, but platform independent. So you still say, okay, this user interface will be for touch, but you don't specify which platform of touch. You just specify the modality, for example. And the final user interface is the actual source code that is being generated that the users interact with. In terms of this chameleon reference framework, our approach maps like this, where with UIML we describe the abstract user interface, and XForms represents our concrete user interfaces, which in terms XForms is transformed into XHTML, which is our final user interface. And we did some modifications to this meta interface model and to the UIML, namely this cross-referencing of different elements across these different tags. Also scrapped some elements, and changed some ideas for the preference and precedence and conflict resolutions that is done in UML. Because UML is XML-based, so it's pretty much, you can define your parts everywhere in the document. But we decided to use some strict rules for this. And we decided to change the peers component, not get rid of it entirely, but since our target was XForms, we use XL transformations and basically our XForms is built from the XSL transformations. And then the logic is mapped according to the behavior that we specify in our interface. For example, this is a small snippet which illustrates one of the changes. Here we have a simple two parts, which should be rendered like two buttons, a yes and no button, for example. And we can see that it has different, it has a lot of tags and different ways how you reference one ID from how you reference the style for one part, and how you reference its content and so on. But we decided to simplify this to using only unique IDs, and this is one of the changes we did to the model and to the mappings of between elements. So it's much more readable, less to generate and parse, and it's simpler. The transformation process, first we do some XSLT processing of the very UML document, and we then arrive at an XForms representation which contains all the elements, all the submission, all the data parameters, all the models, everything that you would need for a valid HTML document with XForms. These two steps represent the abstract user interface to concrete user interface transformations. And also here we make add some references to CSS files if needed, or JavaScript files. And then there is the transformations. With an XML transformation of choice, we do transform this XML document to be rendered into the browser, since there is no native support in browsers for XForms. And yeah, we result in an HTML output which is styled according to the CSS styles provided at step 2. And these two steps represent the concrete to the final user interface. And so this approach, we decided to wrap it around a tool, so such that we make a proof of concept and check if this end-user development could work. And by end-user development, we mean it's meant the notion that you can involve non-professional experts and domain experts into the development of graphical user interfaces. And there are usually two paradigms in terms of user interfaces. Is the what you see is what you get type of editors. For example, Microsoft Word is one such editor, because, and then what you see is what you mean. We decided to use the second paradigm, since the difference is that the editing view and the final representation doesn't need to be very tightly coupled. So you capture, you present, it's still a graphical representation, but it's more on a semantical level, and it was easier to implement for our proof of concept. And for the web, it also brings some advantages when you target the web platform, since different browsers and different devices render things differently. The editor basically has two, it has a normal user view and a developer view. The developer is the guy with the glasses. And the developer can change the XOT transformations, can edit or create new CSS inside the editor and change the UML source code and so on. And the user views mainly the UML source code and the graphical representations. And as a case study, here is one game, which is more or less entirely developed on XML technologies with Xforms, XOT, XQuery. It's a browser game where you control a village and you have a population and you manage the village resources and so on. And for example, with the editor, we can do elements of this user interface. For example, this navigation menu at the bottom left corner. So that's a screenshot of the editor. It's been sized down to fit on a swipe, but you have here some insertion of layouts and so on. Nothing has been inserted yet. But for example, this is how you would insert an image button. You would type in where the image is located, what should happen when you click on that image. You just specify the method, and then you map this with the application logic that you provide separately. And you provide a unique ID, of course, so that you can insert it. And this is the what you see is what you mean perspective. You just see here some layouts which are nested into each other, and you have different elements, but they're not represented in the final form. It's just still a graphical representation, but more on a semantical level. And at the bottom of the screen, you get the generated or the marshaled UIML code. After transformation, you get a result, which is here in our case an Xforms document that finally rendered into the browser with an Xforms implementation of choice. Looks like on the actual game. And so of course our goal was to present this, to explore this idea of model-based user interface development with XML technologies, namely UIML for description language and XOT for transformations. But nevertheless, there are a lot of improvements that are ahead and perhaps need to be done in terms of the model transformations, like model-to-model and model-to-code transformations, in order to support more and more UI metaphors and more devices. And as mentioned in this Chameleon reference framework, there is this task model level as well, which we don't currently cover, but with some technologies such as concurrent task trees, which is a common representation of tasks in the model-based user interface development environment, or currently the emerging state chart XML could be also an option. And last but not least, the editor needs to be vastly improved in order to support an actual end-user development and being able to produce high-fidelity user interfaces in future. And that's all. Thank you for the attention. Do you have any questions?
Right. We have plenty of time for questions. Okay, whilst people are thinking, I have a question. You mentioned SC XML. Is the choice of that over XProc, is that because of the event-driven nature of using SC XML?
Yes, and you can represent with the state chart XML, you can capture some flow of interaction, some tasks. So we have considered it could be a valuable selection for capturing this abstraction level.
Right. Any other questions? Oh,
Hi, Murray. Hello? Okay. So, very interesting presentation. And I'm sorry, but the editor in me feels a need to tell you something. In order to be parallel with WYSIWYG, I think you need to be what you mean is what you get, or what you mean is what you see. It's just a parallelism.
Well, we resorted to using what you see is what you mean, since we currently target only X forms for the web platform, and some of the idea was that for the web platform your user interfaces it's difficult to be consistent across different browsers and different devices. But if you target different platforms, sure, there is a huge advantage of using what you see is what you get, because this is a lot more easier intuitive for users. So for future, what you see is what you get is perhaps a better approach, a better way to go.
Right. Any other questions? Okay. Thank you very much.